In this video, we're going to be tackling homogeneous differential equations. Now, what is a homogeneous DE? Well, a homogeneous DE means that every term has the same degree. A degree is in here, so x to the 1, y to the 2. The degree of this term is 3. And in here, also 3, since 2 plus 1 equals 3. So if all the terms have the same degree, barring the constant, since that's just zero, then we can consider the differential equation to be homogeneous. So we can use homogeneous techniques in order to solve this. Now, if there is one term that isn't degree 3, then you can't do this because then it would not be homogeneous anymore. You have to use another set. And one more thing, for example, you had something like this. Uh, the degree of this would still be 3. This doesn't matter. This doesn't matter if it's there or not. It's not part of the degree solving, so you need to ignore it and then you can proceed with your solutions. But anyway, we don't have that situation in this solution, so we will be proceeding with homogeneous solution. So how do we solve these? Well, one of the things you could do is to multiply this by either 1 over x cubed or 1 over y cubed. Whichever it is, it's your choice, and it depends on the equation. You have like e to the y over x. Then you have to multiply by 1 over x cubed so that every term will be y over x. You'll see what I mean. So in here, if we multiply 1 over x cubed here, we will get 4 times x squared gets cancelled out, leaving us with 1 over x, so it's y over x, plus x will cancel out, so it will leave us with x squared, and then dy equals 0. This is if you multiplied 1 over x cubed. Can we do that with 1 over y cubed? We can. Let's try it. Let's try it here. So 4x squared, then y gets cancelled, leaving us with y squared, plus uh, x times y squared is cancelled, leaving us with 1 over y. So uh, y dy oh, I forgot that, equals 0. You can use either of these and it will work. We will get into the same answer, but it's up to you to use. I would want to use this one for now to make it simpler. So next step here is to equate y over x equals to v or y equals xv. Some textbooks actually skip all of this and go directly to this, but that is a possible solution to here. But I prefer this because I can see what's going on, right? Under the hood, if you will. So we have to find the derivative of this. So derivative of y is just dy. Since this is the dy and dx form, we will use dy. If this was like y prime form, we would use y prime instead of dy. But this is the dy and dx form, so we will use dy. So derivative of this side requires uh, the product rules. So first derivative of the first, so that will be dx times the second plus the first times the derivative of the second. So v dx plus x dv. So that's what you have to keep in mind. Now, let's substitute y over x as v. So we get 4v dx plus y squared over x squared is v squared, since y over x quantity squared is the same. And dy is this, as we've discussed, v dx plus x dv. Equate that to 0. So now here we can solve this, right? We don't know if we can solve it yet. So let's simplify things, right? So we can see if it is indeed solvable. Look at this. There's dx here, there's dx here. That's a common factor. So we can factor that out. We can combine this. We get v cubed and we have 4v here. factor dx out, we get this as the first part. And then the other side, we get, well, there's only dv. There's only one dv. So it's x times v squared uh, dv. Now, this is now separable. So let's divide both sides by x and this 4v plus v cubed. So we get dx over x plus v squared on top and 4v plus v cubed on the bottom. We can factor v out of there. We get 4 plus v squared times v here, like that. And then dv, don't forget, equals 0. Now, here we can start integrating like this, like you would for a separable differential equation. V and v squared cancel each other out, leaving us with v on top. And, well, we know that the derivative of the bottom is 2v. So let's put 2v here and 1/2 here, just in case. Uh, the integral of dx over x we all know is ln of x. 1/2 times this is the ln of 4 plus v squared. Let's just put that there. And then we need to find the integral of 0, which is just c on one side. So there we go. To make it easier, let's multiply both sides by 2. So 2 ln x plus ln of 4 plus v squared equals, c is a constant, multiplied by 2, still a constant, so we will put c. Usually I would put markers 1, 2 here, but it's not necessary. So let's just put c in here for a constant. It's just one constant, so we're going to be fine. Now, we have ln's here. We can combine them using the laws of logarithms, but there's a multiplier of 2 here. So let's put this 2 here into the exponent of x, like this. Let me rewrite 4 plus. V is y over x, so we can put y squared over x squared here right now, and then that will equal c. Let's multiply the inputs together since laws of logarithms. So ln of x squared times 4 plus y squared over x squared equals c. Now we can work on two things at once here. We can raise e to both sides. This ln would cancel out. E to the c. C is a constant. E to the c is another constant. That's just c constant. So that it will remain there. It will not remain unchanged. It's just that this will be on another constant, just c. On this one, on the inside, we can multiply x squared to both sides, distribute. So x squared times 4 is 4x squared. Y squared over x squared times x squared. X squared cancels each other out, so we get y squared equals c. And that is your general solution. Okay, so here's a short recap. All right, we move on to the next one. Also another similar problem. We have x squared y prime equals 3xy plus y squared. Is this homogeneous? Let's see. The degree of this one is 2. The degree of this one is 1 plus 1, which is 2. The degree of this is 2, making this homogeneous. So you can use the homogeneous equations here. You can use another technique here, actually. You can use a Bernoulli technique, which I have covered. But we can use homogeneous in here, so let's do that first. What do you want to use first? Well, there's y prime here, so something along the lines of y equals xv might be better than than x equals yv, and this is v equals y over x. Again, this is v equals x over y. So what are we going to use? Oh, this is more useful to us since if you find the derivative of this y prime, then something something something. So basically, we have isolated y here, and here it's hard to isolate y really. So without using the quotient rule, so we will divide both sides by x squared. So multiply by 1 x squared both sides. We get y prime here, and on here we get 3 times y over x since x cancels out the one x here, leaving us with 1 over x. And then here, there's no canceling, so y squared over x squared. Nice. From here, we can again substitute y over x to be equal to v. And again, this is y over xv. So we can use the y prime notation here. And x is, derivative of x is just 1. And derivative of v, I will have it later actually. So times v plus x times derivative of v. This is with respect to x because, well, it usually is in this format. So x does not need like an x prime because x prime is just 1 with respect to x. So that's it. Substitute y prime on the left hand side, we get v plus x v prime. Substitute y over x as v on both sides, we get 3v plus v squared. Right. Notice we can put v on the other side to get xv prime equals v squared plus 2v. Since there's v on one side, v prime, we need to transfer this to the other side. So we get v prime over v squared plus 2v. On the other side, we get the x, we need to transfer to on the other side, so we get 1 over x. All right. So from here, we can integrate both sides with respect to x. And how do we integrate this with respect to x? Well, remember, v prime is dv over dx, which means that we are reversing the implicit differentiation that would have happened if we gotten like v as with respect to x, right? Basically, v prime is just the permission from x to integrate in v, something like that. So we can replace this with dv if you want, but that would be. The important thing in here is that we have to write v times v plus 2. This means we have to do partial fractions. So a over v plus b over v plus 2. Let's combine them together. A times v plus 2 plus b times v over v times v plus 2. We know the numerator is 1. So how can we solve this? Well, one shortcut here, if you don't want to do the algebra thing, is to equate v to something that would make either this or this 0. So maybe v equates to like negative 2. Let's erase the denominator here. We don't need it for now. So v equals negative 2. What happens here? A gets multiplied by 0, but b gets multiplied by negative 2, leaving b. So with a gone, we get b to the negative b times negative 2, sorry, equals 1, and b has to be negative 1 half. Since b has to be negative 1 half, we can go back here and uh substitute for negative b, but let's do the other one. What would make bv 0? Well, just b equals 0. So this then becomes a times 0 plus 2 times plus, sorry, b times 0 equals 1. B times 0 is just 0, so it's gone. And then this, we have to divide both sides by 2 in order to get 1 half. So this is then 1 half times 1 over dv minus 1 half times dv over v plus 2. All right. So from here, we can combine both aspects of the integral, both aspects of the differential equation, because we know this, that, and this. So let's combine them down here. Let me just copy this one. That and like that. All right. All right. Let's integrate all of this together. dv over v is ln v. dv over v plus 2 is just ln of v plus 2. Cool. And then this is ln of x. Then, of course, don't forget plus c. Multiply both sides by 2 in order to remove the 1 half. So we get ln of v minus ln of v plus 2, which then equates to 2 ln x plus 2 times a constant, still a constant, so we can safely put c here. Now, let's combine these two together using the laws of logarithms. So we get v over v plus 2. And then on the other side, let's put this on the powers to get ln of x squared. Raise e to both sides. Uh, don't forget plus c. And raise e to both sides. E and ln cancel each other out. We get v over v plus 2 on one side. And on the other side, we get e to the ln of x squared plus c, which can be e to the ln of x squared, e to the c. E to the c is another constant. Since c is a constant, e to the c is a constant. So we can put this as constant c. Then e to the ln x, we can cancel e and ln x to get x squared. And this is almost the answer. We have to transform v into y over x again. So y over x over y over x plus 2 being equal to cx squared. All right, one more time. So x squared cx squared equals multiply both the numerator and denominator by x in order to get y over y plus 2x. This is the answer. If you want, you can divide by a constant in order to get a constant. So we can isolate x squared here. And then y over y plus 2x. Again, dividing by a constant is still a constant. And constant divided by itself is just 1. So that takes care of that. Now, if you don't like this answer and you want it in terms of y, you can do that. Let's try doing that. So x squared times y plus 2x equals cy, right? Maybe that's your final answer if your teacher hates like multi-line answers like this one. He doesn't like fractions. This could be your final answer. But let's try to isolate y from here if your teacher likes to isolate y. So x squared y plus 2x cubed equals cy. Transfer this to both sides, transfer that to both sides. If we transpose this to both sides, this would become negative cy. And negative of a constant is still a constant. So we can still safely say plus cy. Right? Again, let me reiterate. Minus cy. Minus c is still a constant. So this could be another c. Okay? C changes every time we say it changes, but it would remain a constant, an arbitrary constant. So don't worry about it. Then on the other side, we got negative 2x cubed. Okay. So now, we can isolate y by doing this. X squared plus c, then negative 2x cubed on both sides. Divide both sides by x cubed plus c if you want. And then we are left with negative 2x cubed over x squared plus c, which I think is what happens when you put it in online calculators. So that's going to be the answer for this one, and that's going to be homogeneous. So I'll see you in the next video.